I'm sure you've heard the news. Science is awesome. But did you know Muslim scholars help make it cool? Muhammad bin Musa was great at math. Jabir ibn Hayyan mixed up potions, and Al-Kindi loved asking big questions. They were like the superheroes of learning. Who knows, maybe you'll be next. Jabir ibn Hayyan died 803 CE. Jabir ibn Hayyan, the alchemist Geber of the Middle Ages, is generally known as the father of chemistry. Abu Musa, Jabir ibn Hayyan, sometimes called Al-Harani and Al-Sufi, was the son of the druggist Attar. The precise date of his birth is the subject of some discussion, but it is established that he practiced medicine and alchemy in Kufa around 776 CE. He is reported to have studied under Imam Jafar Sadiq and the Umayyad prince Khalid ibn Yazid. In his early days, he practiced medicine and was under the patronage of the Barmaki vizier during the Abbasid Caliphate of Harun al-Rashid. He shared some of the effects of the downfall of the Barmakis and was placed under house arrest in Kufa, where he died in 803 CE. Jabir's major contribution was in the field of chemistry. He introduced experimental investigation into alchemy, which rapidly changed its character into modern chemistry. On the ruins of his well-known laboratory remained after centuries, but his fame rests on over 100 monumental treatises, of which 22 relate to chemistry and alchemy. His contribution of fundamental importance to chemistry includes perfection of scientific techniques such as crystallization, distillation, calcination, sublimation, and evaporation, and development of several instruments for the same. The fact of early development of chemistry as a distinct branch of science by the Arabs, instead of the earlier vague ideas, is well established, and the very name chemistry is derived from the Arabic word alchemia, which was studied and developed extensively by the Muslim scientists. Perhaps Jabir's major practical achievement was the discovery of mineral and other acids, which he prepared for the first time in his alembic and beak. Apart from several contributions of basic nature to alchemy, involving largely the preparation of new compounds and development of chemical methods, he also developed a number of applied chemical processes, thus becoming a pioneer in the field of applied science. His achievements in this field include preparation of various metals, development of steel, dyeing of cloth and tanning of leather, varnishing of waterproof cloth, use of manganese dioxide in glassmaking, prevention of rusting, lettering in gold, identification of paints, greases, etc. During the course of these practical endeavors, he also developed aqua regia to dissolve gold. The alembic is his great invention which made easy and systematic the process of distillation. Jabir laid great stress on experimentation and accuracy in his work. Based on their properties, he has described 3 distinct types of substances. First, spirits, that is those which vaporize on heating, like camphor, arsenic, and ammonium chloride. Secondly, metals, for example, gold, silver, lead, copper, iron, and thirdly, the category of compounds which can be converted into powders. He thus paved the way for such later classification as metals, nonmetals, and volatile substances. Although known as an alchemist, he did not seem to have seriously pursued the preparation of noble metals as an alchemist. Instead, he devoted his effort to the development of basic chemical methods and study of mechanisms of chemical reactions in themselves, and thus helped evolve chemistry as a science from the legends of alchemy. He emphasized that in chemical reactions, definite quantities of various substances are involved and thus can be said to have paved the way for the law of constant proportions. A large number of books are included in his corpus. Apart from chemistry, he also contributed to other sciences such as medicine and astronomy. His books on chemistry, including his Kitab al-Kimya and Kitab al-Sabin, were translated into Latin and various European languages. These translations were popular in Europe for several centuries and have influenced the evolution of modern chemistry. Several technical terms devised by Jabir, such as alkali, are today found in various European languages and have become part of scientific vocabulary. Only a few of his books have been edited and published, while several others preserved in Arabic have yet to be annotated and published. Doubts have been expressed as to whether all the voluminous work included in the corpus is his own contribution or it contains later commentaries, additions by his followers. According to Sarton, the true worth of his work would only be known when all his books have been edited and published. His religious views and philosophical concepts embodied in the corpus have been criticized, but, apart from the question of their authenticity, it is to be emphasized that the major contribution of Jabir lies in the field of chemistry and not in religion. His various breakthroughs, for example, preparation of acids for the first time, notably nitric, hydrochloric, citric, and tartaric acids, and emphasis on systematic experimentation are outstanding, and it is on the basis of such work that he can justly be regarded as the father of modern chemistry. In the words of Max Meyerhoff, the development of chemistry in Europe can be traced directly to Jabir ibn Hayyan. Muhammad bin Musa died 840 CE. Abu Abdullah Muhammad ibn Musa al-Khawarizmi was born at Khawarizm, Kava, south of Aral Sea. Very little is known about his early life, except for the fact that his parents had migrated to a place south of Baghdad. The exact dates of his birth and death are also not known, but it is established that he flourished under al-Mamun at Baghdad through 813, 833, and probably died around 840 CE. To celebrate the 1200th birth anniversary of Muhammad bin Musa al-Khawarizmi, the former USSR issued this postal stamp pictured on top. The terms algebra and algorithm are familiar to all of us, but how many have heard of their founder Muhammad al-Khawarizmi? In geography, he revised and corrected Ptolemy's view and produced the first map of the known world in 830 CE. He worked on measuring the volume and circumference of the Earth and contributed to work related to clocks, sundials, and astrolabes. His life Abu Abdallah Muhammad ibn Musa al-Khawarizmi. The last mentioned name, his Nisba, refers to his birthplace, Khwarizm, modern Khiva, south of the Aral Sea. He was born around 780 in the town of Kath, part of Khwarizm. Kath is now buried in the sand. He died around 850. He was summoned to Baghdad by Caliph al-Mamun and appointed court astronomer. From the title of his work, Hisab al-Jabr wal Muqabala, Book of Calculations, Restoration and Reduction, Algebra, al-Jabr, derived its name. Algebra symbolizes the debt of Western culture to Muslim mathematics. Ironically, when it first entered the English language, it was used as a term for setting of broken bones, and even sometimes for the fractures themselves. This reflects the original literal meaning of the Arabic word al-Jabr, the reuniting of broken bones, from the verb jabara reunite. The anatomical connotations of this were adopted when the word was borrowed as algebra into Spanish, Italian, and medieval Latin, from one or other of which English acquired it. In Arabic, however, it had long been applied to the solving of algebraic equations. The full Arabic expression was ilm al-Jabr wal Muqabala, the science of reunion and equations, and the mathematician al-Khawarizmi used al-Jabr as the title of his treatise on algebra. In the 12th century, Gerard of Cremona and Roberts of Chester translated the algebra of al-Khawarizmi into Latin. Mathematicians used it all over the world until the 16th century. A Latin translation of a Muslim arithmetic text was discovered in 1857 CE at the University of Cambridge Library. Entitled Algoritmi de Numero Indorum, the work opens with the words, "Spoken has algoritmi. Let us give deserved praise to God, our leader and defender." It is believed that this is a copy of al-Khawarizmi's arithmetic text, which was translated into Latin in the 12th century by Adelard of Bath, an English scholar. Al-Khawarizmi left his name to the history of mathematics in the form of algorism, the old name for arithmetic. His work, al-Khawarizmi, was a mathematician, astronomer, and geographer. He was perhaps one of the greatest mathematicians who ever lived, as, in fact, he was the founder of several branches and basic concepts of mathematics. In the words of Philip Hitti, he influenced mathematical thought to a greater extent than any other medieval writer. His work on algebra was outstanding, as he not only initiated the subject in a systematic form, but he also developed it to the extent of giving analytical solutions of linear and quadratic equations, which established him as the founder of algebra. Hisab al-Jabr wal Muqabala contains analytical solutions of linear and quadratic equations, and its author may be called one of the founders of analysis or algebra as distinct from geometry. He also gives geometrical solutions with figures of quadratic equations, for example x2 plus 1 ox equals sign 39, an equation often repeated by later writers. The Liber Isa Gogarum Algorismi in Artem Astro, Nomicam a Magistro A, Adelard of Bath Compositus, deals with arithmetic, geometry, music, and astronomy. It is possibly a summary of Al-Khawarizmi's teachings rather than an original work. His astronomical and trigonometric tables, revised by Maslama al-Majriti, second half of 10th century, were translated into Latin as early as L126 by Adelard of Bath. They were the first Muslim tables and contained not simply the sine function but also the tangent, Maslama's interpolation. His arithmetic synthesized Greek and Hindu knowledge, and also contained his own contribution of fundamental importance to mathematics and science. Thus, he explained the use of zero, a numeral of fundamental importance developed by the Arabs. Similarly, he developed the decimal system so that the overall system of numerals, algorithm or algorithm, is named after him. In addition to introducing the Indian system of numerals, now generally known as Arabic numerals, he developed at length several arithmetical procedures, including operations on fractions. It was through his work that the system of numerals was first introduced to Arabs and later to Europe, through its translations in European languages. He developed in detail trigonometric tables containing the sine functions, which were probably extrapolated to tangent functions by Maslamaty. He also perfected the geometric representation of conic sections and developed the calculus of two errors, which practically led him to the concept of differentiation. He is also reported to have collaborated in the degree measurements ordered by Al-Mamun, which were aimed at measuring a volume and circumference of the Earth. His books. Several of his books were translated into Latin in the early 12th century. In fact, his book on arithmetic, Kitab al-Jama wal Tafriq bil Hisab al-Hindi, was lost in Arabic but survived in a Latin translation. His astronomical tables were also translated into European languages and, later, into Chinese. His geography captioned Kitab Surat al-Ard, the face of the earth, together with its maps, was also translated. In addition, he wrote a book on the Jewish calendar, Istikraj Tariq al-Yahud, and 2 books on the astrolabe. He also wrote Kitab al-Tariq, and his book on sundials was captioned Kitab al-Rukmat, but both of them have been lost. A servant of God. Al-Khawarizmi emphasized that he wrote his algebra book to serve the practical needs of the people concerning matters of inheritance, legacies, partition, lawsuits, and commerce. He considered his work as worship to God. Quotation from Al-Khawarizmi: "That fondness for science, that affability and condescension which God shows to the learned, that promptitude with which he protects and supports them in the elucidation of obscurities and in the removal of difficulties, has encouraged me to compose a short work on calculating by al-Jabr and al-Muqabala, confining it to what is easiest and most useful in arithmetic." Al-Jabr means restoring, referring to the process of moving a subtracted quantity to the other side of an equation. Al-Muqabala is comparing, and refers to subtracting equal quantities from both sides of an equation. Yaqub ibn Ishaq al-Kindi, 873 CE. Abu Yusuf Yaqub ibn Ishaq al-Kindi was born at Kufa, around 800 CE. His father was an official of Harun al-Rashid. Al-Kindi was a contemporary of al-Mamun, al-Mutasim, and al-Mutawakkil, and flourished largely at Baghdad. He was formerly employed by Mutawakkil as a calligrapher. On account of his philosophical views, Mutawakkil was annoyed with him and confiscated all his books. These were, however, returned later on. He died in 873 CE during the reign of Al-Mu'tamid. Al-Kindi was born and brought up in Kufa, which was a center for Arab culture and learning in the 9th century. This was certainly the right place for Al-Kindi to get the best education possible at this time. Although quite a few details and legends of Al-Kindi's life are given in various sources, these are not all consistent. We shall try to give below details which are fairly well substantiated. According to 3, Al-Kindi's father was the governor of Kufa, as his grandfather had been before him. Certainly all agree that Al-Kindi was descended from the royal Kinda tribe which had originated in southern Arabia. This tribe had united a number of tribes and reached a position of prominence in the 5th and 6th centuries, but then lost power from the middle of the 6th century. However, descendants of the royal Kinda continued to hold prominent court positions in Muslim times. After beginning his education in Kufa, Al-Kindi moved to Baghdad to complete his studies, and there he quickly achieved fame for his scholarship. He came to the attention of the Caliph Al-Mamun, who was at that time setting up the House of Wisdom in Baghdad. Al-Mamun had won an armed struggle against his brother in 813 and became caliph in that year. He ruled his empire, first from Merv, then, after 818, he ruled from Baghdad, where he had to go to put down an attempted coup. Al-Mamun was a patron of learning and founded an academy called the House of Wisdom, where Greek philosophical and scientific works were translated. Al-Kindi was appointed by Al-Mamun to the House of Wisdom together with Al-Khwarizmi and the Banu Musa brothers. The main task that Al-Kindi and his colleagues undertook in the House of Wisdom involved the translation of Greek scientific manuscripts. Al-Mamun had built up a library of manuscripts, the first major library to be set up since that at Alexandria, collecting important works from Byzantium. In addition to the House of Wisdom, Al-Mamun set up observatories in which Muslim astronomers could build on the knowledge acquired by earlier peoples. In 833, Al-Mamun died and was succeeded by his brother Al-Mutasim. Al-Kindi continued to be in favor, and Al-Mutasim employed Al-Kindi to tutor his son Ahmad. Al-Mutasim died in 842 and was succeeded by Al-Wathiq, who, in turn, was succeeded as caliph in 847 by Al-Mutawakkil. Under both these caliphs, Al-Kindi fared less well. It is not entirely clear whether this was because of his religious views or because of internal arguments and rivalry between the scholars in the House of Wisdom. Certainly, Al-Mutawakkil persecuted all non-Orthodox and non-Muslim groups while he had synagogues and churches in Baghdad destroyed. However, Al-Kindi's lack of interest in religious argument can be seen in the topics on which he wrote. He appears to coexist with the worldview of Orthodox Islam. In fact, most of Al-Kindi's philosophical writings seem designed to show that he believed that the pursuit of philosophy is compatible with Islam. This would seem to indicate that it is more probably that Al-Kindi became one, the victim of such rivals as the mathematicians Banu Musa and the astrologer Abu Mashar. It is claimed that the Banu Musa brothers caused Al-Kindi to lose favor with Al-Mutawakkil to the extent that he had him beaten, and gave Al-Kindi's library to the Banu Musa brothers. Al-Kindi was best known as a philosopher, but he was also a mathematician and scientist of importance. 3. To his people he became known as the philosopher of the Arabs. He was the only notable philosopher of pure Arabian blood and the first one in Islam. Al-Kindi was the most learned of his age, unique among his contemporaries in the knowledge of the totality of ancient scientists, embracing logic, philosophy, geometry, mathematics, music, and astrology. Perhaps rather surprisingly for a man of such learning who was employed to translate Greek texts, Al-Kindi does not appear to have been fluent enough in Greek to do the translation himself. Rather, he polished the translations made by others and wrote commentaries on many Greek works. Clearly, he was most strongly by the writings of Aristotle, but the influence of Plato, Porphyry, and Proclus can also be seen in Al-Kindi's ideas. We should certainly not give the impression that Al-Kindi merely borrowed from these earlier writers, for he built their ideas into an overall scheme which was certainly his own invention. Al-Kindi wrote many works on arithmetic which included manuscripts on Indian numbers, the harmony of numbers, lines and multiplication with numbers, relative quantities, measuring proportion in time, and numerical procedures in cancellation. He also wrote on space and time, both of which he believed were finite, proving his assertion with a paradox of the infinite. Garrow gives Al-Kindi proof that the existence of an actual infinite body or magnitude leads to a contradiction in 7. In his more recent paper, 8, Garrow formulates the informal axiomatics of Al-Kindi's paradox of the infinite in modern terms, and discusses the paradox both from a mathematical and philosophical point of view. In geometry, Al-Kindi wrote, among other works, on the theory of parallels. He gave a lemma investigating the possibility of exhibiting pairs of lines in the plane which are simultaneously non-parallel and non-intersecting. Also related to geometry was the 2 works he wrote on optics, although he followed the usual practice of the time and confused the theory of light and the theory of vision. Perhaps Al-Kindi's own words give the best indication of what he attempted to do in all his work. In the introduction to one of his books he wrote, see for example 1, "It is good that we endeavor in this book, as is our habit in all subjects, to recall that concerning which the ancients have said everything in the past, that is the easiest and shortest to adopt for those who follow them, and to go further in those areas where they have not said everything." Certainly Al-Kindi tried hard to follow this path. For example, in his work on optics he is critical of a Greek description by Anthemius of how a mirror was used to set a ship on fire during a battle. Al-Kindi adopts a more scientific approach. See for example 1. Anthemius should not have accepted information without proof. He tells us how to construct a mirror from which 24 rays are reflected on a single point, without showing how to establish the point where the rays unite at a given distance from the middle of the mirror's surface. We, on the other hand, have described this with as much evidence as our ability permits, furnishing what was missing, for he has not mentioned a definite distance. Much of Al-Kindi's work remains to be studied closely, or has only recently been subjected to scholarly research. For example, Al-Kindi's commentary on Archimedes' The Measurement of the Circle has only received careful attention as recently as the 1993 publication 10 by Rashed. In chemistry, he opposed the idea that base metals can be converted to precious metals. In contrast to prevailing alchemical views, he was emphatic that chemical reactions cannot bring about the transformation of elements. In physics, he made rich contributions to geometrical optics and wrote a book on it. This book later on provided guidance and inspiration to such eminent scientists as Roger Bacon. In medicine, his chief contribution comprises the fact that he was the first to systematically determine the doses to be administered of all the drugs known at his time. This resolved the conflicting views prevailing among physicians on the dosage that caused difficulties in writing recipes. Very little was known on the scientific aspects of music in his time. He pointed out that the various notes that combine to produce harmony have a specific pitch each. Thus, notes with too low or too high a pitch are non-pleatant. The degree of harmony depends on the frequency of notes, etc. He also pointed out the fact that when a sound is produced, it generates waves in the air which strike the eardrum. His work contains a notation on the determination of pitch. He was a prolific writer. The total number of books written by him was 241, the prominent among which were divided as follows: Astronomy 16, Arithmetic 11, Geometry 32, Medicine 22, Physics 12, Philosophy 22, Logic 9, Psychology 5, and Music 7. In addition, various monographs written by him concern tides, astronomical instruments, rocks, precious stones, etc. He was also an early translator of Greek works into Arabic, but this fact has largely been overshadowed by his numerous original writings. It is unfortunate that most of his books are no longer extant, but those existing speak very high of his standard of scholarship and contribution. He was known as Al-Kindus in Latin, and a large number of his books were translated into Latin by Gerard of Cremona. His books that were translated into Latin during the Middle Ages comprise Risala dar Tanjim, Ikhtiyarat al-Ayam, Ilahiyat Aristu, Al-Musika, Mado Jazr, and Aduiya Murakaba. Al-Kindi's influence on development of science and philosophy was significant in the revival of sciences in that period. In the Middle Ages, Cardano considered him as one of the 12 greatest minds. His works, in fact, lead to further development of various subjects for centuries, notably physics, mathematics, medicine, and music.